Have you ever wondered what makes an AI system smart or intelligent? It's not as simple as it might seem. Figuring out how to define and measure machine intelligence is one of the biggest challenges as AI technology keeps advancing. On this episode of Dany on Tech, we'll dive deep into this complex issue. I'll break down the different ways researchers are trying to understand and evaluate AI intelligence. We'll look at measuring specific skills versus general cognitive abilities. I'll share real-world examples of how intelligence gets measured for different types of AI, from manufacturing robots to digital assistants like Siri and Alexa. And we'll discuss why getting AI intelligence measurement right is so important for developing safe AI systems, improving human-AI collaboration, and potentially even recognizing human-level general intelligence one day. This topic draws from many different fields like computer science, neuroscience, and philosophy. So get ready to exercise your brain as we try cracking the code on AI intelligence. So let's dive in. Welcome to Dany's podcast on technology. I'm your host, Daniel Parente, here to talk all things tech and keep you plugged into the latest innovations and trends on the market. As professional writer and professor in the field of technology, my goal is to break down complex technology topics into bite-sized discussions for everyone. I'm thrilled you are along for the ride. Grab a snack, settle in, and let's have some fun. What exactly makes an artificial intelligence system intelligent or smart? It's a tricky question that researchers have defined in many different ways. One common approach looks at how well an AI performs specific tasks as a measure of its intelligence. We call this task-based benchmarking. For example, an AI that can beat human champions at complex games like chess or Go would be considered highly intelligent for that narrow skill. However, critics argue that just being a master at one particular task doesn't fully capture what we mean by broad intelligence. An AI might excel at a game simply because it's really good at recognizing patterns for that game's rules, not because it has general smarts that work for any situation. So do we only measure narrow task skills? Or do we aim for evaluating more flexible cognitive abilities like reasoning, learning, and problem solving that aren't tied to just one scenario? A new perspective from computer science theory formally defines intelligence as skill acquisition efficiency. The core idea is to look at how well an AI can take its initial training and expand its skills through experience to handle many different types of situations. The key factors are the variety of scenarios the AI can handle, how easily it transfers skills to new areas, what prior knowledge it started with, and its ability to learn and generalize from experience. Researchers created a benchmark called the abstraction and reasoning corpus to evaluate this kind of flexible, generalizable, fluid intelligence that we see in humans. But calculating an exact skill acquisition efficiency score for an AI is incredibly difficult. There's also an ongoing debate around whether AI should try mimicking biological intelligence found in things like the human brain and neural networks. Some argue modeling AI on biological systems will lead to better general intelligence. Others say the principles behind biological and artificial intelligence may be too different. Researchers have also looked at applying frameworks we use to understand human cognitive abilities and intelligence, like Bloom's taxonomy, to evaluate AI systems. For example, an AI that simply retrieves facts might be at the remembering level, while one that can create new solutions would be at the highest creating level. These different perspectives show there's no one agreed way to define and measure machine intelligence yet. The criteria depends on the type of AI system and what capabilities we care about evaluating. For narrow AI assistants like Siri or Alexa, we might prioritize measures around language processing, knowledge retrieval, reasoning abilities, and continuous learning. But for autonomous robots operating in the real world, we'd also need to assess skills like sensory perception, navigation, decision-making, and self-awareness. And for hypothetical future artificial general intelligence or AGI that could match human-level intelligence, we'd likely need comprehensive benchmarks looking at reasoning, learning, creativity, social skills, and more. There are also important real-world reasons we need to make progress on AI intelligence measurement. First, having clear evaluation criteria allows AI developers to set defined targets and benchmarks to work towards during the training process. Second, standardized methods for assessing an AI's intelligence level will be critical for ensuring systems behave as intended when deployed and don't become too unpredictable or unsafe as they become more advanced and autonomous. Third, by clearly measuring the strengths of different AIs, we can better decide what types of tasks are best suited for machines versus humans in collaborative centaur teams. An AI great at data processing could take the lead on those duties, while strategic decision-making relies more on human intelligence. As the quest to properly define and measure AI intelligence continues, researchers are grappling with some key considerations. Should we strive for a single standardized way to measure machine intelligence across all systems? That would allow for easy comparisons. But the downside is oversimplifying the complex concept of intelligence into one number or score. Or should we have specialized assessments tailored to each AI's intended use case and capabilities? This avoids oversimplification, but makes cross-system evaluations trickier. There's also the question of how much we should model intelligence measures on human benchmarks and performance. Comparisons to human intelligence provide valuable context now, but may become obsolete if AI eventually surpasses biological capabilities. Another issue is keeping up with AI's rapid progress. Static, fixed benchmarks risk becoming outdated as the technology quickly evolves. So do we need intelligence measures that can dynamically adjust to changing AI capabilities over time? Finally, defining AI intelligence isn't just a technical challenge. It has major societal implications around workforce policies, legal liability for AI mistakes, privacy regulations, and public trust in AI systems. We'll need robust governance informed by ethical principles. There are no easy answers, but collectively resolving these questions will shape humanity's ability to develop safe, controllable AI aligned with our values and interests. The quest to measure machine intelligence is a complex, multidisciplinary puzzle spanning computer science, neuroscience, philosophy, and more. It's an eternal quest without a clear final destination. As AI capabilities rapidly evolve, our measuring sticks of machine smarts must continuously evolve as well. By diligently redefining and requantifying intelligence, we'll unlock deeper insights into the nature of intelligence itself, both artificial and biological. While solving the riddle may be a perpetual pursuit, it's one we must persist at. The future of controllable, transparent AI systems depend on our ability to truly understand and evaluate machine intelligence in all its dimensions. And that wraps up another fun and hope-interesting episode of Dany's podcast on technology. As always, hit subscribe and ding that notification bell to join me next time. I had a blast geeking out over today's topic with you all. Feel free to connect on social media with any questions, comments, or suggestions for future episodes. I can't wait to connect more in the comments and bring another dynamic technology conversation your way soon. Until next time, my fellow tech heads, this is your host signing off. Stay curious and keep looking forward, my friends. The future awaits.